Okay, here is a review problem that I'm going to do to get you ready for the P chapter test. I'm going to try to periodically give you some problems that are good examples of what you can expect on your upcoming test. So what I decided to do for this problem is to look at rational functions. Rational functions can sometimes give students a lot of difficulty. So I'm going to start with a rational function. We're going to have y equals, rational equation I should say, x squared minus x minus 6 over x plus 5. And I want to talk about all the different questions that can be asked about this particular problem. We are going to find x-intercepts. We're going to find y-intercepts. We're going to talk about the domain of this equation. And we could go even further and talk about the graph. We do have a graphing calculator that'll help us, but we can at least talk about what we should expect to see on our calculator. So first we're going to talk about x-intercepts. Keep in mind that x-intercepts happen when y equals 0. So what this is really saying is, when does this entire equation equal 0? Now, when you're dealing with a rational function, to make this 0, the only thing we need to worry about is the numerator. If the numerator is 0, then we get 0, because 0 divided by anything in the bottom gives us 0. We don't have to worry about the denominator. If the denominator equals 0, it doesn't equal 0. It is undefined. So we're going to forget about the x plus 5 for a second and just focus on the top. If I want to know when something equals 0, it needs to be in factored form. So one of our favorite things to do is we get to factor this polynomial. It does factor very nicely, and you'll see that. If it doesn't factor nicely, you have to use the quadratic formula, but that really doesn't happen much. What you end up getting when you factor it is x plus 2, x minus 3. That means your x-intercepts are at -2 and +3. You might see it written like that. You might see it written as -2, 0, 3, 0, because it's the places where y equals 0. So that's how you find your answers for your x-intercepts. If it is not rational, then you just set the whole thing equal to 0 and factor. If it's already factored, then that makes it even easier. Y-intercepts are the easiest intercepts to find. A lot of times I'll do it first just because I know how quick it is. Y-intercepts is saying what happens when x is 0. When I do that, all I'm doing is putting 0 everywhere I see an x. So I'm going to get 0 minus 6 on top, over 0 plus 5, which is 5. So my y-intercept is -6/5. You may see it written as 0, -6/5. That is the exact point where it crosses the y-axis. So now we have 3 points in our graph. We have the 2 points where it crosses the x-axis and the 1 point where it crosses the y-axis. And then finally, what's going to be asked often, especially with rational functions, is what about the domain? Now, when you think about domain and domain restrictions, there are 2 issues. There is a situation where you can never have 0 in the denominator, or you cannot have a negative under an even root. Well, we don't have any roots, so we don't have to worry about that. All we're worried about now, when we look at our equation, once again, this time we only care about the denominator. We do not care about this numerator. We want to know what makes the denominator equal 0. Because the denominator equals 0, then it is undefined. So in this case, no factoring necessary. We know that x cannot equal -5. There's a lot of ways to write this as a domain. You could write all real numbers except x can't equal -5. You could say from -infinity to -5. And then from -5 to infinity, just don't use brackets. In words, I think it's easier just to list the exceptions. X can be everything except for it can't be -5. When you graph this on your calculator, what you'll notice is it has a vertical asymptote, and we'll talk more about asymptotes as we go through this class, at x equals -5. So you'll see the 2 parts kind of go close to that and then go up. A lot of times this looks a lot like a hyperbola whenever you graph it. This is a problem that you'll see show up a lot of different ways on your test. You'll be asked questions about finding different intercepts. You'll be asked questions about domain and about the visual of a function. So hopefully this will help you get ready for your test. Thanks.